Hello. Today I want to tell you something about the differences between encryption and hashing. You will bump into these terms quite often if you read anything about cryptography and blockchain systems. They share some similarities, but they serve a totally different function. You should think about encryption as a two-way process. This is the biggest difference between them, and a process which is reversible. On the other hand, hashing is irreversible and it's a one-way process. Usually when you encrypt something, you are doing this with the intention of decrypting it later. I already talked a lot about asymmetric and symmetric cryptography, and you can check it in my previous videos, real examples, how are you using keys to encrypt and decrypt data later on. As I said, hashing is a one-way process. It's irreversible. The process of hashing is the following. You have a certain input data. It can be in any kind of format. Then you need to choose a hashing function. There are many hashing functions available. One of the most frequently used is the SHA-256. You put this piece of data through this hashing function and you would get a fixed size output. If you use the SHA-256, as the name implies, you will get an output which is 256 bits long. From this output value is called the hash. You cannot get back the original data from the hash value. Hash functions have two very important properties. The first one is this output value. The hash value is always fixed size. As I said, if you're using SHA-256, your output size will be 256 bits long. That's the first important property. So no matter how big the input size is, the data of the input size is, you will always get a fixed size output. For this, of course, if you're using the same hash function. And the second important property is if you slightly change the input value. Let's say your input value is some kind of text and you append a space or you append a character to your text. The output hash will be totally different. The output hash is very random. It will be totally different if you slightly change the input value. And this is a very important property of hash functions, and it's heavily utilized in proof of work, for example. It's the consensus algorithm used on Bitcoin and many other cryptocurrencies. But I will talk about this in my later videos. Hashing functions were originally used to check if some piece of data was modified, if the piece of data was altered in the process of, let's say, sending that piece of data through a network. You will check if the piece of data was modified by hashing that piece of data and then sending the original data with the embedded hash. And then the receiver can again hash that same piece of data and check his hash and the embedded hash. If these two hashes match, it means that the data hasn't been altered. Another usage of hashing functions is storing passwords in a database. Of course, you would never want to store a password as a plain text in the database. If someone steals your database, he knows all of your users' information. What you would do is hash the password and save the hashed value of a password in your database. So when the user first signs up for your application with his password and username, you would hash the password, save it as hashed value in the database, and then later on when the user signs in, your backend would hash his sign-in password and check if these two hashes match. If they match, you would let him in the application. Of course, there are many more usages of hashing, and it's heavily utilized in blockchains as well. I will show you one of the usages of hashing in my next video on digital signatures. Okay, thanks.